Okay, we have retained another integral. This one's from MIT 2023 quarterfinals, round 1, problem 2. We have this integral with a whole bunch of cosines with different angles in it. We've got 4 cosines subtracting from another expression with 4 cosines dx. Okay, to be honest with you, I don't really like these problems all that much. We have this formula. We know we can do it because we've got this formula to reduce it over here. The trouble with it is this only helps us with 2 cosines, right? So it's good for any 2 cosines. I mean, we don't have to choose them, and we could choose them in any order. The thing I don't like is the method on this is usually just to apply this over and over and over again. Well, my method might not be a lot better, but I want to do it a little bit differently. One thing we can do on this formula, what happens if I multiply in another cosine? Like if I multiply in cosine C, let's say. Well, if I multiply in a third cosine, we get this expression on the right, but then we're back to having 2 cosines, right? So then we would just go back and apply this formula again. The same thing with this one, we apply the formula again. Let's see what we have. And now we have this formula here for 3 cosines. Notice we went from 1/2 on this formula to 1/4 here. We went from 2 terms to 4 terms. In any of these cases, notice this. What happens is for the angle, we get every combination of A, B, and C. You may think we don't have the minus on the A. That's just because cosine's an even function. Like coming back, like looking at this one right here, cosine of A plus B. We could have cosine minus A minus B, but with an even function, it's just going to change the sign back. So but because it's an even function, the sign gets changed back, and this is the same as this. So that's why we don't have to have like literally every combination, because some of them are going to be equivalent with the even function. Well, it turns out just looking at our formula for 3 cosines, this pattern just continues like this on and on forever. So if we have 4 cosines, the way this is going to work, if we look at how many cosines we have, the number out front is going to be 1 over 2. If n here is 4, it's going to be this n minus 1. And this number here is the same thing as the number of terms. So this is going to be 2 to the n minus 1 terms. But if n's 4, we know what this is. 4 minus 1, 3, 2 cubed. This is going to be 1/8. And so over here, we can say we're going to have 8 terms. And again, we're just going to need every combination assigned. So to get started with it, all I want to do is get rid of all this junk and just use this single formula right here that we're going to have for each of these. We're going to have 2 of them as we're subtracting. For each of these, we're going to have 1/8 times the 8 terms, but every combination of the angles. So honestly, it's still a little tedious because I still had to go through and get my 8 terms for each, so 16 terms. So like the first one, 21, that's just adding up 3 plus 5 plus 6 plus 7. And then what I did for the other ones is I went through and subtracted one of the terms, and then I subtracted 2 of the terms, etc., until I got my 8, and I just did the same thing on each of these. We have the 1/8 in common here, so we could actually factor that out of the whole thing. But now here, because we've got the minus sign on this one, I can just go and find every common term. We can cancel that out. Like here we have cosine x and cosine x, cosine 3x, cosine 3x, cosine 7x, cosine 11x, cosine 15x, cosine 5x here, and then cosine 9x. So almost everything cancels up, but we're left with this term and this term. Factor 1/8 out, and what we're left with here is going to be 1/8 times cosine 21x plus cosine 13x. But now at this point, we just need to remember that we're working on an integral. I'll get rid of the equal sign because we're not equal to this. We're going to integrate this now. So we'll just throw in the integral sign and integrate with respect to x. So we'll go ahead. We've got the 1/8 in front. Integral here, this is going to be sine 21x over 21. And then for the next one, this one's going to be sine 13x over 13. Add a plus c, and that's it. So basically, I think this one's all about trying to find some little shortcut or some time savings to just kind of make it a little less tedious and a little quicker. So, okay, so there you go. Kind of a tedious problem from MIT 2023. Thanks so much for watching. Have a good day.